The sky is no longer empty. Thousands of satellites and millions of debris fragments race around our planets at unimaginable speeds. Every second, potential disasters loom. Collisions that can destroy satellites, disturb the communication, and trigger cascading debris. How do we protect space, the final frontier, from this chaos? Hello, Thales team. My name is Sakshi Chilkoti, and I am representing my team, the Techs, in the Thales GenTech Hackathon 2025. The space traffic is becoming increasingly complex. Satellites, debris, and new launches create a dynamic and congested orbital environment. Traditional SSA, Space Situational Awareness Systems developed by the Thales, provide robust monitoring and manned operations. But AI driven predicted automation is still the next frontier. Meet our project Aerospace. Aerospace builds on this vision of Thales. It combines real life tracking, predictive analysis, and collision avoidance, along with 3D visualization of the debris and meteors and other satellite systems, all in order to bring Thales SSA philosophy to the next generation autonomous orbital safety systems. So, our project is a AI powered orbital situational and space traffic management system. It is inspired by Thales' ELENA Space Situational Awareness Program and the space traffic management tools. It uses raw orbital data and converts it into actionable intelligence, enhancing safety, efficiency, and automation for satellite operations. Now, if you see here, this is our front page designed as a gateway to intelligent space operations. Here we present the mission overview, the real life metrics, showing the number of active satellites and debris management being tracked. All orbital data is sourced from TLE dataset and processed to stimulate trajectories in near equal time. Now, the first thing is our visualization tool. Here is a 3D visualization module built with Three.js and React.js. All the satellites and debris are rendered as interactive objects. Users can zoom, pan, and click on a website or a meteor or its path to see its trajectory in real time. All the data of the meteors or the derbies are also provided with this 3D tool. Now, the second thing is a AI collision prediction panel. This panel represents Astrospace Predictive Intelligence Engine. We use a hybrid AI model combining LSTM models for temporal prediction trajectories and CNN layers for spatial risk analysis. This engine calculates the CPI, collision probability indices, for each satellite or debris objects and generates recommended invasive maneuvers. If you see here, if you do the simulation of the time and number of steps and run the simulation, you can see that this machine learning model, it represents the data graphically, and this graphical data can be used to analyze and predict further things in this. So in summary, this astrospace platform transforms reactive orbital monitoring into a proactive AI driven and visually analyzed system, aligning with Hale's mission to make aerospace operations easier, smarter, and more autonomous. This platform is a glimpse into the future of space traffic management. It is intelligent, predictable, and sustainable. Hi, Thales team. After our presentation of the project, I think the most important thing for a project is for it to be actually purposeful and useful with the existing technology that we work with. Like the project should be used in a real world technology for it to be successful. I can give you a path or a more clearer idea of what we are trying to build. So, for example, in a real life operation system like the Thales space ops or Skyfile mission control, aerospace can be deployed as like a decision support dashboard. Like operators would see real-time satellites and debris position. It is manned and unmanned yet, but in the future prospect, I know we are all working for the AI automation, and right now we are in the stage where it is both manned and unmanned operation, where the unmanned operation is providing more support and more accuracy to the manned operation. So the operators would see real-time satellites and debris positions in 3D alongside AI generated risk scores, which would be a future prospect, which are machine learning model, that it can predict that what would be the risk scores, maybe in the form of red graphs or green graphs, that we can show signals we can show, or we can even make it interactive like giving signals. That is just a future prospect which we would love to work with you in the future. And our USP for the project is of course our 3D model, because everything is just, when it is more interactive, it is easier to see. So our platform, instead of manually cross referring multiple data sets, aerospace will consolidate tracking, prediction and visualization in one interface. Like imagine a Thales mission controller is monitoring a commercial satellite constellation, and it can see which satellite are on collision course and receive AI recommended maneuvers from it. We are planning to integrate and to upgrade the level of AI that you people at Thales are working on, and we want to share our innovative idea in this, especially in the field of 3D visualization and training the machine learning model.